Alright, this is part 2 of operations of polynomials, and in this video we are going to subtract two polynomials and see. Okay, the first one we already have two functions. The first is f of x equal to 3x square minus 4x plus 12, and the second function g of x equal to 5x square plus 7x minus 8. Okay, so let us find what is f of x minus g of x. So the first function f of x is 3x square minus 4x plus 12 minus your g of x is 5x square plus 7x minus 8. And we are going to find the difference between those two polynomials. So in the first part here, I don't have to do anything to the first function f of x. So let us just copy 3x square minus 4x plus 12. Only thing is I removed the parentheses. Then in the second part, for the function g of x, as I take away these parentheses, this negative sign in fact is multiplied with all the terms. Or you can also say I'm using a distributive property, and let us take 1 as a number because nothing is there. So 1 times whatever you multiply, the resulting number is going to be the same, but only the sign changes. That's why we usually say that just change the sign as you remove the parentheses, right? So 5x square, there is no sign beside 5x square, so by default it is positive. So positive sign, now I have to change it to minus. It is minus 5x square plus 7x becomes minus 7x, and minus 8 change to plus 8. So this second function, the function which is being subtracted, I have to change their sign. That's the only thing I have to remember. Plus 5x square change to minus 5x square, plus 7x is minus 7x, and that negative 8 change to positive 8. Okay, now let us put the like terms together, write them down. That is 3x square minus 5x square, those two are there. Next, minus 4x minus 7x plus 12 plus 8. Alright, so 3x square minus 5x square, that is from 3 I am taking away 5. So 3 minus 5 is 2 with a negative sign. That is 5 minus 3 is 2. Bigger number is negative, so that's the thing. Minus 2x square minus 4x and minus 7x, like negative 4 and negative 7 put together gives you negative 11. Just add those two numbers because the signs are same. Add them and copy the same sign. That is negative 11 and x. Don't do anything to the exponents. X square just remains as x square. Now lastly, 12 plus 8, that gives you 20. So this is the difference of the two polynomials f of x and g of x. Alright, so that's the difference you got. And sometimes you may be asked to find what is 3 times f of x, 3 f of x minus 2 times g of x. In this case also, I'll just follow the same process. I need 3 times f of x. So 3, your f of x is 3x square minus 4x plus 12 minus 2 times g of x is 5x square plus 7x minus 8. Alright, then I'll make use of distributive property. It is distributive property. Okay, so now what distributive property states? That is 3 times 3x square gives me 3 times 3, 9x square, and then 3 times negative 4, so negative 12, and x is already there, and 3 times 12 is 36. This thing. Next, minus 2 times 5x square minus 10x square we got. Then again minus 2 times 7x minus 14x minus 2 times minus 8 gives you plus 16. Okay, now let us write the like terms together. 9x square minus 10x square minus 12x minus 14x plus 36 plus 16. These are the like terms. So that 9x square minus 10x square minus 12x and minus 14x, then 36 plus 16. So what next? 9x square minus 10x squared gives me, from 10 take away 9, that is 1x squared, just x squared, and 10 has a negative sign, so I can write negative. And this 1 you don't have to write, you can just, even if you say it is negative x square, it means that it is negative 1x square, but for our understanding I just included 1 there. Now what is negative 12x and negative 14x? That gives me negative 26x. Add those two numbers and put a negative sign. And lastly 36 and 16 both are positive, add them together, we got 52. So this is the result of f 3 times f of x minus 2 times g of x. Overall, what we can understand is the difference of polynomials is also a polynomial. Hence, the subtraction of polynomials is, polynomials are closed under subtraction. I should have said that. Okay. Thank you.